5.5 miles to the west. And the area's busiest commuter bridge, the San Francisco-Oakland Bay Bridge, runs right between the two. It was in 1989 when Loma Prieta hit San Francisco, a 7.1 magnitude earthquake that devastated the city. It interrupted the World Series, killed 62 people, and rendered the east span of the Bay Bridge, the third busiest bridge in the world, structurally unstable. The quake stretched the bridge apart, causing a 50-foot-long, 250-ton section of the upper deck to collapse. Crews repaired the damage and reopened the bridge a month later, but it was left vulnerable to a complete collapse in the next major earthquake. So right now, to protect the city, architects, engineers, and the government are coming together in the single largest public works project in the history of California. They're attempting to build a new Bay Bridge. Costing $7.2 billion, this 8-mile-long bridge, made up of 2 unique spans, is getting completely overhauled. On the west span, the double suspension bridge was flexible enough to survive the earthquake. All it needed was reinforcement. But on the east span, the original truss bridge was just too rigid for earthquakes and too weakened from the collapse, so it's getting completely replaced. The new span will be one of the most seismically advanced bridges in the world. An unprecedented type of structure, strong enough to withstand a magnitude 8 earthquake, by designing parts of the bridge to stretch and even break. So by design, you know what piece is going to break during an earthquake?
Yes.
Which is a very different logic than how the old Bay Bridge was built.
That's right. We are engineering the seismic performance of the bridge.
So while they were trying to make their bridge as robust and as strong as possible, in some ways, you're trying to make your bridge fail in specific places.
And engineered specific places, yes.
So you're actually controlling the failure.
Yes.
By channeling failure to specific areas, engineers can protect the key structural parts of the bridge, like the tower. The single tower will be unlike anything ever built, divided into 4 interconnected legs. They're joined by 120 shear link beams, which will move and absorb seismic energy deforming during an earthquake. The beams can then be replaced in just a few days, thereby protecting the tower from serious damage. It's the first time that this technology has ever been used on a bridge. So during an earthquake, when this thing starts to move, all the damaging force of that quake gets directed right here at these shear link beams.
That's right.
They break, you replace them, the bridge still stands.
That's right. And you design them like the bumper on your car. You're driving your car, you have a little accident, the fender deforms, but you can still drive your car.
So instead of trying to battle the earthquake, you're kind of just rolling with it.
That's right.
The new road deck is also designed to roll along with an earthquake. It can stretch more than 3 feet due to special hinge pipe beams embedded inside. These giant shock absorbers make the new span 9 times more flexible than the original Bay Bridge. But directing flexibility into these specific areas means the rest of the road deck has to be bound firm, so it won't be stretched apart in an earthquake. Crews working on the new span are joining together 28 individual bridge segments into one solid roadway through a massive job of bolting and welding. This is happening right now on the first 4 segments of the eastbound lanes, which will carry drivers into Oakland. Okay, so Daniel, we're now standing at the very edge of the segment. Yeah. And while the bridge wants to have a decent amount of movement to cope with the movement of an earthquake, the deck itself, you want that to be totally rigid.
Yeah, it's completely continuous.
No gaps, no breaks, no nothing.
Exactly.
And you have to line up how many bolt holes from the next piece to this piece?
There's about 4,500 bolts.
4,500 bolt holes.
Yep, pretty substantial.
4,500 of these holes below me.
Correct. They'd have to line up perfectly.
And how much wiggle room do you have with the bolts?
There's about 1 millimeter oversize around each hole.
Oh, so it's not that big a deal. So of the 4,500 bolts, you have a good millimeter to play with to really just ease the two together.
Yeah, exactly.
Is this the most complicated bridge in the world?
I think it is.
Coming down.
4,500 bolts make up just one seam.
So you have a team right now that's connecting two of the segments?
Yeah.
In total, the 28 bridge segments will be bound together from the inside with more than 350,000 bolts.
Daryl?
How you doing?
I'm Danny.
Daryl.
How are you?
Good to meet you. Doing good.
Daryl, tell me what's going on up here.
Well, we got bolting it up, connecting it together, trying to line the bolts up first with the pins so the bolts go in easier.
So basically smacking a pin, and by doing so, when that pin goes through, it should kind of pull up the steel and get those holes together?
Exactly.
Because I think the thing to remember is that that's an old piece, that's a new piece. Both were made in China, shipped over here. It's jet lagged. The steel is beat. And now you gotta get the steel, two different pieces within 1 millimeter of each other.
Yeah.
Let's smack in a pin. Lead the way.
Let me grab this half pin right here.
In order to align the bolt holes, crews start by pounding pins into the stiffening ribs that line the top of the segment, temporarily holding the pieces together.
That should line us up.
That was very loud, Daryl.
Yeah. Well, I guess you should have had earplugs on. I'm used to it, so.
And by used to it, you mean hearing impaired.
Yes. Yes.
Okay, so now the pin is in.
They want 6 in each side.
Right about there?
Yeah, the other one there.
This is going to be a complicated swing. Daryl, this is not, like, there's not exactly free range of motion here.
Yeah, you're limited. Go hit it easy first. Get your motion first, and then you can get more force on it.
Come right up under this little space. Right there.
There you go. And you don't want to choke up on the beater too much, because if you choke up on it too much and you do happen to miss, this is going to hit your hand. So you need to make sure you keep your hand back away from the head of that bolt. Hit it lightly first, next to the head of the hand.
My hand's up here, and I miss. I'm just going to break my finger.
Yes, you're going to break all them fingers. If not, partially take some of them off. You keep your hand away from the beater.
All right, choking down on the beater.
That's it.
Nice little soft hit. And then
That's okay. A couple of scratches won't hurt
it's
it.
a big bridge. I mean, this thing's designed to take earthquakes, for God's sake.
Yeah. There you go. Just have to keep your eye on the pin. Yeah. Like that. See? Very good.
Not bad, is it?
You're hired.
Not bad, is it? I got all of them.
Good job.
I got all of them. All right, so now the pin is in place, which means the alignment is good between one plate and the next plate.
Ready for bolts.
The team's using 1-inch diameter, high-strength bolts for the connection.
That's one.
A major improvement on the original Bay Bridge.
I mean, they didn't have bolts in there, did they?
No, it was rivets.
Rivets.
Yes.
Which is essentially like a pin going through.
Yes. New world.
New world, right?
Yes.
On the old Bay Bridge, they used hot steel rivets. Once cooled, they expand to hold the steel plates together, but their smooth surface allows for a small amount of wiggle room between the segments. The new Bay Bridge is designed to move only in specific places, so these threaded bolts lock the segments together and won't slip at all during an earthquake.
You just bounced that nut off somebody's head down there.
Sorry.
Crews have just 1 week to install all 4,500 bolts, locking the two road segments together on the inside, allowing welders to finish the job on the outside.
How's she look?
Good. Fantastic.
And there you have it. 36 bolts on one piece of this bridge. But keep in mind, there are 4,500 bolts wrapping around this entire segment. And there are 28 segments on the entire job, which means by the time you drive your car over the New Bay Bridge, Daryl will have done a lot of bolting.
Yes, a lot of bolts.
Up next, surviving the worst earthquakes ever encountered.
You're floating.
Take some of the heaviest lifts ever attempted.
You don't often see 5 lanes of traffic floating over your head. The San Francisco Bay Area is located on top of some of the most seismically active geology in America. Now, statistically speaking, there's an over 60% chance that a massive earthquake will hit this town in the next 20 years. So when designing a bridge to span the bay, when it comes down to earthquakes, it's not so much if, but when.
It's been 20 years since the last major earthquake hit the Bay Area, and the next one could be more than 40 times stronger. So California is racing to make sure the Bay Bridge is ready before something like this happens again.
So that image of the top section collapsing onto the bottom section stayed with you.
Yeah, it's burned in everybody's mind. And if you went to our construction offices, in every single office, there's that picture on the front door. And the reason why it's there is to remind us every day that we need to keep going fast to try and get this bridge in service.
Because, I mean, there really is an actual non-negotiable deadline in that bridge, if a big quake hits, I mean, it's going to go down.
That's right.
To fortify this vulnerable bridge, the east span is getting completely replaced with this seismically advanced new span built right next to the old one. It's the world's first ever single tower, self-anchored suspension bridge.
To really appreciate how a self-anchored suspension bridge works, you got to understand how a traditional suspension bridge works first. And what better example than the west span of the Bay Bridge? Now you have your vertical towers. You then have your horizontal road deck. And from the towers hang the incredible swooping cables that hold up the road deck, but anchor into massive foundations both on land and in the middle of the bay. However, on the east side, we don't have the geology to support these loads. So in this bridge, you have your vertical tower. You still have your horizontal road deck. But as the cables come swooping down, instead of anchoring into the earth, they anchor into the road deck itself. Hence the term, a self-anchored suspension bridge. So Marwan, the cable is anchored into the road deck. And that same cable comes up, goes into the tower, comes down, makes a U-turn, goes up and down again. That's one single cable.
It is one single cable.
And it doesn't die into the anchorage, doesn't go into the earth. It actually ties into the road deck. That's right.
It anchors on the east ends on either side, and it loops around here.
And so as the cable comes down and around the bridge, almost like a belt around my waist, it's both holding up the road deck, but also pushing it together, making it tighter and stronger.
That's right.
Has that been done before?
No.
To build this final piece of the new east span, crews are lifting the road deck in 28 massive segments, 14 for the eastbound lanes and 14 for the westbound. The first 4 pieces of the eastbound side are already up and being bolted together. Right now, they're about to make the very first lift on the westbound side, a steel segment weighing more than a submarine that will hang 150 feet above the water.
Before the bridge segment can get picked up and put into place, they have to ready the crane. And to do that, they're attaching a 200 metric ton frame to the front of that, the left coast lifter.
It's one of the biggest and strongest cranes in the country. But even this football field-sized lifter can't do the job alone, because each segment is a different size and weight, and as a result, each lift has a different center of gravity. So to solve this problem, a customized lifting frame was built to attach to the crane that can easily adjust to accommodate the different segments.
So this big yellow steel apparatus that I'm walking on right now is the lifting frame, and it's this thing that connects to the bridge segment and picks it up and puts it in place. But the goal now is to attach this whole lifting frame to the left coast lifter. To do that, we're going to use these 4 massive shackles behind me and connect them to these 4 pad eyes in the 4 corners of the lifting frame. Okay, there we go.
Each shackle weighs as much as a Volkswagen Beetle.
You're gonna get killed by a shackle.
All right, Ryan, coming down.
They're so heavy, the team uses a separate crane to lift them over to the pad eyes.
Boom up, hold your load.
Okay, it's coming in. All right, up and over. God, look at that thing. It almost looks like a joke shackle, like a paper mache shackle. It's so big. Like you went to a store and there was like a shackle holiday and they made this.
All right, boom down, hold your load.
Oh, there it is, the pin. Give me a push. Nice.
Get that come along hooked up.
The crew then uses a hand-operated winch called a come-along to pull the shackle towards the pad eye.
So, as I advance the come along, the shackle is getting closer.
On the work, right?
Killing me here. You okay, Carlos?
I'm good, keep going.
You're not tired, right?
No, I'm tired of looking at you. We can get you a 24-hour membership.
Yeah, wouldn't want to inconvenience you, buddy.
Get ugly with it, Danny. Get ugly with it.
Give me a push.
To get the pin back through, the nearly 1-ton shackle needs to line up within 1/8 of an inch of the pad eye.
How we doing?
We're getting close. You're almost there, looking good.
Right there, it's right there, right there, right there. You got it?
Yeah!
Very nice. Look at that. 4th shackle, nuts being screwed on, which means this lifting frame, all 200 plus tons of it, is ready to go for the 1,000 metric ton lift.
With the frame securely attached, the left coast lifter can now raise it 100 feet, clearing the way for a barge to float the bridge segment in beneath it.
Piece is coming
There
right
it is,
in
right there. There's the piece. Man, that is large. Wow.
This segment will carry 5 lanes of traffic and weighs as much as a fully loaded 747. Crews have to lift it 15 stories above the water.
What's so amazing about the way you're building this is that although we're talking about a 10, 15-year construction window, the Bay Bridge is going to grow today. The morning commuters to San Francisco and Oakland are going to see that bridge extend for the first time on the west side.
Today's the first time they'll get to see it.
Did you ever see that? People are driving, they're like, oh my God.
I think they do that every day. We're probably a distraction to the morning commute, but you know, we're the kind of distraction the people of San Francisco want because they want this bridge. Its first 80 feet will be up there by lunchtime today.
The team has to move quickly to finish the lift,
Going up?
because the segment needs to be at full height during high tide. The crane relies on that extra 3 feet of water to get the piece into place,
Are they rigging?
They're getting ready, Tim.
which means this lift has got to be done before the tide goes back down in just 4 hours.
All right, so the left coast lifter is now connected at 6 points to the bridge segment on which I'm standing. 5 separate lanes of traffic. We're gonna pick the piece up, put it in the air, push it into position, and land it right up there.
Coming up, Dan! You guys get out of there?
So essentially, now that the 6 pieces are connected, you're gonna talk to the crane operator
Right.
and begin the lift.
That's a pretty good sight. It's 1,200 tons dangling in the air. Hopefully the wind will calm down and everything will be good.
And all before lunch.
Right.
You gotta get off.
Got to get off.
Coming up.
You guys can't be up here.
All right, Ed's happy with the position. We're gonna get off this thing because in about
See you guys over there.
2 minutes time, this piece of highway is going up.
Holding on the northwest, Ed.
Thanks, Mike. Okay, we're ready to come up. Okay, Ryan, let's boom up.
All right, you're part way up, Dan. All right, you're floating.
All stop.
All stop. In position.
10-4. What was your ultimate weight there?
All 30.
Copy that.
All right, so levels look good?
Yes. We'll go back to the load up, boom up.
Load up, boom up.
That's enormous. You don't often see a chunk of a bridge, 5 lanes of traffic, floating over your head.
The crane lifts the piece at about 5 feet per minute.
Kevin will get a few turns.
And how's it looking?
Pretty good.
It takes a half hour to reach the height of the bridge deck, where another crew waits to begin the most dangerous part of the lift.
All right, so the piece is now up. It's about 150 feet in the air. I'm gonna go hop in a crew boat, go across the bay, up, and land it.
Coming up, landing more than 2 million pounds of steel
Oh, it's coming down. Okay, it's coming down. We gotta get up.
right on top of our heads. And later,
I'm standing atop a cable on one of the most beautiful bridges in the world. And I'm gonna do something a little bit ridiculous.
crews are lifting a 1,000-ton road segment, 150 feet to the height of the New Bay Bridge, an earthquake-resistant, self-anchored suspension span.
Sign off here?
Yeah.
Look at that. That is what it's about. So from here on in, no more handrails.
The team now faces the most difficult part of the lift, safely landing the segment. The massive piece of steel that will hold 5 lanes of traffic has got to be lowered onto the support structure with a margin of error that's less than 1/10 of an inch.
Okay, I'm standing on top of the cradle, which is the temporary structure on which that
1,000 metric ton piece of bridge is about to land. And if you look closely, you can see it's coming towards us. So we're at the right height, bringing the piece up over the temporary steel. Oh, he's got hands on it. Look, he's got hands on it. Wow. Look at this. The piece is now floating over my head into position, and the left coast lifter has to push it about another 20 feet, and we're there. My God, this is like landing a spacecraft on top of your head.
The team lowers the segment onto 8 landing pads. If the weight is not evenly distributed on each pad, it could damage the steel segment. So they cover them with a high-strength protective coating they call gouache.
And it's just eyeball, you don't have to get it.
It gets applied at the very last minute to keep from hardening too soon, meaning the crews actually climb underneath the 2 million pound segment.
So, Bill, let's be very upfront about the situation. There's something over our heads right now.
Yeah, that's correct.
The goal is to move as quickly as possible so we can get out of the way of the load and drop it down in these 8 points.
That's absolutely right.
Okay, so talk to me about this gouache. Talk to me about this,
This is a 2-part epoxy grout, and what we're trying to do is distribute the weight evenly so there's 100% contact between the plate and the bottom of the steel while it's resting on these cradles.
So if there's any mistakes in the steel, it'll get taken up by this lovely, smooth, fast-acting gouache.
That's correct.
So why do you call it gouache?
Gouache is just a nickname we gave it because it's the best way to describe the sound the material makes when it gets displaced under the heavy load. We couldn't spell.
there is no, how does one spell?
Exactly.
Because I thought you named it gouache because it's kind of gouchy.
It is also kind of gouache.
It's kind of gouache.
We kind of like it.
Look at that face, Bill. You know what's great about you is that you're able to have a sense of humor with that over top your head.
With all 8 landing pads safely covered in gouache,
oh, it's coming down. Okay, it's coming down. We gotta get off.
the crane lowers the segment the final few inches onto the cradle, completing this lift.
The weight of the over 1,000 metric ton segment has been transferred from the crane down to the cradle. The rods are up, the piece has landed, which means they have, at long last, taken this first westbound road deck and put it into its final location. And in doing that, they've extended this new connection between San Francisco and Oakland by 84 more feet.
The incredible new self-anchored suspension bridge will be a dramatic addition to the San Francisco skyline. The look of the bridge takes its cue from its other iconic neighbors.
San Francisco is known for its beautiful bridges. In fact, the Golden Gate Bridge is probably the most famous bridge in the world. So when they decided to make a new east span for the Bay Bridge, it wasn't enough to get some steel and span across the bay. They had to develop a signature span that could stand up to competition like that. You know, Marwan, as an engineer, you're faced with a challenge of creating a span that goes over water that can survive an earthquake. Mm-hmm. But if you're an engineer in the Bay Area, you're also tasked with making a bridge that becomes an icon.
That's right. Citizens felt that the Bay Area deserved better, and a signature span of similar magnitude to what the Golden Gate offers. It's a daunting challenge.
Because people here in the Bay Area take the swoop of those cables very seriously.
That's right.
And so the idea is, as you come out of that tunnel leaving the West Span, seeing those iconic swooping cables, the second you drive out, you see them again.
You see them again, and you see them dying down, and then you've got the Berkeley Hills in front of you, so it just tells a beautiful story.
This will be the first time that the design of the east span matches the rest of the bridge. With the new self-anchored suspension span, the look of the cables will continue across the bay to fit seamlessly with the west span. This double suspension bridge has been a Bay Area icon for almost 75 years, thanks to its 4 miles of swooping cables. They're dramatically lit every night with more than 1,200 bulbs, known as the String of Pearls. Keeping these signature lights shining bright is one of the most difficult jobs on the entire bridge.
Today, I'm gonna do something that I never thought I'd do. I'm gonna get onto the cable of the Bay Bridge, walk up that cable to change a light bulb. All right, ready?
Crews have to swap these light bulbs out once every month.
Oh my gosh.
All without stopping traffic on the 3rd busiest bridge in the world.
Russell, tell me what's gonna happen right now.
We're gonna block traffic, we're gonna get off, jump out of the van, and then we're gonna head on up to the cable.
Wait a minute. We're going to the upper deck. Traffic is not stopped. We're going to get out of this van, jump over the side of the bridge, and then climb the cable?
Yes, you all just do is follow me. It's gonna be fun.
The light we're changing is located at the top of the first section of the cable. Now to reach it, we'll be climbing towards San Francisco, nearly 500 feet above the water.
All right, so here we are on the bridge right now. We're getting off? This is it?
Getting off.
All right, here we go, here we go. Go, 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 go. Go, we gotta go, we gotta move. All right. This is ridiculous. Now, before we do this, I just want to point something out. Because of the obscenity of what we're about to do and the kind of difficulty it will be to film it, barring having 3 or 4 helicopters, we've come up with this. It's not sexy. It may not be cool, I'm prepared to admit that, but it will give us a view of this thing that I think we could not have gotten otherwise. So, Russell, what do you think?
I like it.
It's cool, right?
Yep.
The kids at home are going to love it.
You bet they will.
You bet they will. There it is. Pardon the fact that I'm going to look a bit like an elephant. Okay. So, you stay with me. You stay with me, too.
You're gonna follow what I do.
Russell, I will follow everything you do. Okay, a couple of things to point out as we begin our journey together on the cable walk. Number one, I'm walking on a cable. Not the widest surface in the world. It's a cylinder. That's awkward. Secondly, also important to point out, to my left, that's the water. To my right, that's a Mack truck. Oh, boy.
This cable is only 28 inches in diameter.
Coming through, Russell, crossing the threshold.
Don't hit your head.
That's about as wide as a stepladder, but not 1 inch of the surface is flat.
I mean, as you put your 1 foot down, you feel the curvature of the cylinder. I mean, you don't have a single stable surface to put your feet down on. And I'm just gonna say it. I'm gonna say it out loud. This is one of the craziest things I've ever done in my entire life. Whoa, oh my goodness. It moves a little bit, doesn't it?
What?
It moves.
Yep, it's the traffic.
Traffic's really moving the cable.
Mm-hmm, moving the whole bridge.
Well, that's a good thing, right?
Right.
All right, let's keep moving. Come here.
Suspension bridges are designed to move in the event of an earthquake.
Oh my God. Russell, that's a shaky moment there, huh?
Yep.
Man, this bridge moves.
The cable we're walking on can sway up to 3 feet.
1 foot in front of the other. Just a big old balance beam, right?
Yep. Only about 200 more feet.
200 more feet. Dear God. You know what's also sort of amazing about this incredible journey, this ridiculously hard path, in the service of that. This tiny little light bulb, the famous string of pearls that give this bridge its night signature, well, this is what it takes to maintain it, unfortunately. Russell! Oh, it's getting steep now.
Oh, yeah. When you start feeling it a little bit more in your legs.
Just gotta stay focused. It's getting much steeper.
This is the steepest section of the entire cable. The incline gets up to 37 degrees as we approach the top of the tower, 475 feet above the water.
Whoa, don't look down. I look down, I look down, I look down.
What do you think?
What do I think? You know what I think? I think this is the most incredible thing I've ever done in my life.
It's nice, ain't it? Beautiful.
I'm looking at San Francisco in a way that I don't think most people ever get a chance to do.
Nope, not even on postcards.
Unbelievable.
All right, let's move on.
All right, Russell, we're almost at the top. And here are these poor electricians, my God. Are you kidding me?
Ready to change the light bulb.
Of course, the one that breaks has got to be the one at the top, right? All right, show us how it's done. Let's see it.
They've got to take the lens off, which is tied off, so they can't drop it in the bay.
So one man pulls out the dead, sends it back to the partner. Partner then accesses the backpack, and I wish for my sake the backpack was some high-tech light-changing specific device, but it's a knapsack a 4-year-old takes to school. And we replace the light with the good light, and voila, that's it.
That's it.
Light is done.
Yes, it is.
Did we just come up here to do that?
Yes.
You guys think people have any idea what goes into keeping these lights on? 250,000 people cross this bridge every day. Every single night they see this thing shining bright. Well done, fellas. I guess this sort of answered the age-old question of how many guys does it take to change a light bulb?
Minimum of 2.
Takes 2. 2 guys, a backpack, and some serious nerve.
Coming up, rushing to repair the Bay Area's main artery in the middle of the night, while traffic speeds towards us at over 55 miles an hour.
You're getting a heads up. There's a wrong-way driver.
There's actually a wrong-way driver not very far away.
But first, when was the worst earthquake in San Francisco history? The answer after the break. The answer to the trivia question, San Francisco's strongest earthquake, was the 7.9 magnitude Great Quake of 1906.
One of the biggest challenges with building the new signature span of the Bay Bridge, beyond its own engineering complexities, is building one bridge while all the while keeping the existing Bay Bridge up and running.
The busiest bridge in California, the Bay Bridge, carries 280,000 cars each day. Keeping all that traffic moving safely for the next 3 years until the new bridge opens is a construction project unto itself, requiring major repairs to the roadway in the middle of the night.
So, Larry, let's talk a little bit about what time it is right now, because it's not normal working hours.
No, it's not. It's not. I should be home sleeping. You should be home sleeping.
Well, I should be somewhere, but it's definitely 20 minutes to midnight on Saturday night. We're going on the bridge.
Yeah.
We're going to work.
Yes.
I mean, this is a bridge that's over 70 years old. It's in various stages of disrepair. It's been damaged from the '89 earthquake.
Yes.
And your job is to essentially keep this thing up until the new one is ready.
Right. This east span will eventually be demolished. Until then, it's my responsibility to keep this bridge safe for the motoring public.
Right now, the east span is not safe. Crews have to repair a major expansion joint connecting 2 sections of the bridge. To do that, they've closed down 3 lanes of traffic in both the upper and the lower road decks.
Are those our lane closures?
Yes.
Wow. All the way this far back?
Yeah.
Oh, my goodness.
They have to make the repair and get the lanes back open before the morning traffic piles up.
Time to gear up, because once we step outside this car, we're not just on a bridge, we're on a construction site, and that traffic is not stopping for us.
Okay. It's now 1 a.m. Traffic is going. People are still going out in the city. And over here, this is where that expansion joint's been damaged.
The joint allows the road deck to expand and contract during weather, traffic, and earthquakes. It's covered by an 11-inch wide steel plate to keep out debris, because if debris builds up, it could limit the joint's ability to move. After 74 years of constant traffic, the old steel plate is coming loose.
So if you look right here, essentially where I'm standing is one bridge segment, and this is a different one. And right here is the gap in between them. This is the expansion joint, and there's a metal plate below this concrete that's no longer protecting this joint. So today, we're gonna open up this gap, cut out this metal piece, and replace it with a new one to protect that joint.
Crews use an acetylene torch to burn off the bolts holding down the old plate, which will free it from the top of the joint.
So once we've pulled the damaged plate of steel out, this piece right here is what we're replacing it with. So in order to make sure we can weld this piece flush to the deck, all these imperfections, all these bits of slag have to get grinded off to create one flat smooth to give us a perfect weld.
Grinding is the only way to guarantee a lasting weld once this 800-pound replacement plate is laid in and attached to the joint.
It's about 2 in the morning now. I should probably be at a club right now hanging out, chilling. But I'm on a bridge with blocked traffic grinding steel. Saturday night.
This time of night is particularly dangerous on the bridge. So the crew works in front of 2 safety trucks, equipped with a giant crash cushion, designed to absorb the force of a car traveling at 55 miles an hour. But that doesn't do anything if the driver's headed in the wrong direction.
So while we're somewhat protected by our own vehicles, you're getting a heads up from your traffic monitor folks telling you there's a wrong-way driver.
There's actually a wrong-way driver, and California Highway Patrol is trying to apprehend him right now.
Oh, my God. And that's just happening in the background of where we're working.
Right. That's not very far away.
All right, man.
These dangerous overnight repairs happen about 10 times a month. It's the only way to keep this 74-year-old bridge safe until the new one is ready.
So we're out. The damaged pieces come out. You can see the blown out bolt holes right there. That was the problem. That cover had been loose. Cars were hitting it, and it was allowing...
New York, driving there was like driving on the surface of the moon. Covered in ruts, potholes, divots, so forth. And nobody complains.
Nobody complains.
Nobody complains.
And New Yorkers complain about everything.
That's right.
But they will accept all types of potholes.
That's correct.
Here in the Bay Area?
Cannot have segment 1 speed bump in segment 2.
All right, let's grind it well, flatten it out, so you in California can drive your car with a perfect undisturbed surface so you'd never even think you'd left your couch. Shall we?
Yeah.
Grinding is also critical for the bridge's safety. Once drivers are speeding over this roadway at
dirt and debris to get inside the expansion joint. Now that the piece is out, we're gonna clean out the hole and then put down that new piece. So now that you've cut the steel out, what I'm looking at are two separate sections of the bridge, right?
Yes.
So the idea is that your weld won't be a nice tight bond unless you're going clean metal to clean metal.
Exactly.
Otherwise, every single day, every single car looking at is the intersection between two separate pieces, right?
That's correct. This is segment 1, this is segment 2.
Structurally speaking, they are one.
Structurally speaking, they are one.
A tube.
A tube.
a 197-foot-long weld joins two bridge segments together. It's laid down in 9 layers with a robotic welding machine. The top 3 layers, called reinforcement, ensure that the gap is completely filled. But they stick up about 1/4 of an inch above the road deck.
Car would be banging on this piece of steel.
Precisely. It may damage a car, it may cause an accident. I have family and friends across the bridge too, and I want them to be safe.
Gotta get it right.
Yeah, because my weld is my signature.
Once the empty expansion joint is smoothed down and all the old bolts are removed, the crews can finally lower the new plate into place.
And so here it is, the replacement piece of steel. And they're gonna be here for another 3 to 4 hours.
A 180-degree view of the surrounding bay. And right under their wheels will be one of the strongest road decks ever built. Sealed together from the inside with 4,500 threaded bolts per seam, and from the outside with almost 11 miles of weld.
Once all 4,500 bolts have been installed and tensioned, the very last and final step to bring these segments together is the weld. And that final weld is happening right inside here. All right, so John, in that weld line, and I'm welding this piece in solid to create this new expansion joint cover. And it just goes to show you just how much effort it takes to maintain a bridge that is over 70 years old, and why it's so important to get that new span up and running as quickly as possible. Bring it down. Bring it down. Good, okay.
Up next, sealing one of the world's strongest road decks requires one of the largest weld without damaging any of the permanent base material. It'll take these guys 2.5 days to make this entire section perfectly flat.
So, Jeremy, I'm looking at segment 1, segment 2, and this was formerly that humpy weld that was kind of in between the two.
Right.
Look at that now.
Yeah, nice and smooth.
Flush as a baby's butt, were it to be made of metal. That means the next thing that's going to come on here will actually be the road surface itself.
Yep.
And that's what it takes to give you a perfectly flat, smooth surface for the Bay Area's newest and most amazing bridge.
Once all the deck segments are permanently attached and the new Bay Bridge is finished, California will have a safe and stunning new span that can withstand the big quake that geologists are predicting. And a 20-year-long chapter in San Francisco's history will finally come to a close.
So talk to me about what will happen when that bridge is done. What's the significance for this area?
Well, I think it's a lot of things. One, it will remind us of the Loma Prieta earthquake. Even though we just had the 20th anniversary of that earthquake, I think we'll go back to that moment in time again because it is the last thing to be fixed of the damage that we had there. So that's part of what will happen. But then there's this immense relief because we're talking about the safety of an entire region of people.
This is not a typical bridge.
Not in any stretch of the imagination.
You know, I'm finding jobs in the country.
Making a flat road, one grind at a time.
The location of the San Francisco-Oakland Bay Bridge presents a unique paradox for builders. Gorgeous surrounding views atop deadly seismic conditions. When designing the road deck of the new East Span, engineers had to consider both.
The image of the road collapse from the 1989 earthquake is burned into the memory of all Bay Area residents,
creating a hump on a surface that needs to be perfectly smooth.
Because if there's a little hump and they do pour the asphalt down, there could be,
you know, perhaps some kind of divot that somebody might feel somewhere and complain about.
Because while they're driving over this beautiful new Bay Bridge looking at the view, they might feel like a little bum.
That's right. They might feel a little bum.
Spill a latte. Yeah, then their coffee is spilled, bust out a cell phone, call Caltrans and start complaining.
Exactly. Let me tell you something. I lived in New York.
So rather than have the stacked double-decker road deck like on the West Span, they instead separated them into two side-by-side spans, creating not just a safer bridge, but also an amazing view for the driver as they cross the span.
Unlike the original East Span, which enclosed the roadway in steel trusses, the new Bay Bridge will be almost completely open, giving drivers 50 miles an hour. An uneven surface could cause an accident. To keep that from happening, a team of 3 workers has to grind each 197-foot-long weld by hand.
This is your grinder right here.
This is me.
Okay. You got yours, Jeremy. Ken, you got yours.
Hey,
your grinder works.
Wait a second. Look at my grinder.
Yeah.
And look at Jeremy's.
Jeremy's been grinding longer than you have.
Yeah, exactly. It's okay, I have other talents. It is an awfully big grinder, though. All right, I'm ready to rock and roll. Making a flat road, one grind at a time.
Grinding has to be done